Any questions?
There's three of us.
Do you feel like we're missing people?
Yeah, like I know Robin and Erica said they could be late.
I saw Robin. She was at the bus stop.
Yeah, she's probably walking home right now. She usually comes around this
No,
time.
she said she
The
missed
cool
the bus.
people are here, so what more
She
do we
missed the
want?
bus?
Yeah.
Poor gal.
So that's better.
She was there really early.
Anyway, I'm taking the no questions.
Wait, no questions.
Good. Take a look at orbital motion again. C for central object and S for satellite. I mean, if you want to take Earth, Moon, that's fine. Sun, planet, doesn't really matter. I am going to assume a circular orbit. We have an object traveling at constant speed. If it's in a circular orbit, how do we know it has to be a constant speed? Because potentially you could ask the question of, if it weren't at a constant speed, what does that tell you?
I don't know the words to explain it. I feel like when we talked about that it has to fall at a constant rate in
Okay.
order to stay in orbit, so it would somehow overcome the gravity at some point and like fly outside of orbit, or it would be like too slow so gravity would pull it in.
Yeah, pretty much. That ultimately, in terms of forces, that if it were not a circular orbit, that means the force would have to be not perpendicular to the direction of motion, because the velocity is in that direction. The force would be in that direction. So if not in circular motion, these two would not be perpendicular to each other. Therefore, part of the force would have to be either in the direction of velocity or against the direction of velocity, which means that the speed would change. But as it is, only the direction is changing, because I don't have any force helping or hurting the motion. All right, so we can be more specific here in the force diagram. Let's get rid of that. What is that force?
Force, gravitational something.
All right, someone's coming down the, yes. So.
Sorry, the bus never came.
Louder, please.
The force of gravity.
Yes.
Where is everyone?
Now, because there's a force of gravity acting on the central object, this central object is going to wobble some.
Can you tell me what's going
Look
What's the
at
problem?
orbital motion one more time.
on? Okay.
So I have only one force acting on the satellite, pointing towards the center. What's another name for a force pointing towards the center?
Wait. Sorry.
Looking more for,
Centripetal force.
yep, that's the one. I know that F equals ma, or at least it's a basic premise of the course. And so we have F sub G is equal to M A sub C. What is the generalized, what's the force due to gravity? In essence, we're at the substitution phase.
9.8. M over
No.
S squared.
What's the last thing you said?
M over S squared. I didn't know.
What is 9.8 meters per second squared?
Gravity,
Acceleration.
acceleration.
Where?
Going towards the core.
No, not which direction.
On Earth.
Yeah, is the satellite on Earth?
No.
So
You need to be near the surface of the Earth for that 9.8 meters per second squared to be the approximation.
is it not in orbit?
It is in orbit.
So
If
then
it's in
gravity
orbit,
is
it's-
acting on it.
Pardon?
So then gravity is slightly acting on it.
Oh, it is. There was no disagreement with that.
9.8 meters per second squared only works on Earth if you're on the surface. Gravity's weak the further away you go.
Oh, pressure and all that, right.
Not pressure, just the way gravity works.
Yep. The farther you are away, the gravitational force weakens.
For a full pressure acts on mass and all that.
Pressure does, however, if it's in orbit, I'm assuming it's in, to the point where there's really not a lot of gas around it, or fluids in order to exert a pressure. I'm ignoring solar pressure.
The what now?
The pressure that comes from sunlight,
Silver pressure?
solar.
Solar.
All right, so
It's G times M1 times M2 over R squared.
yeah, I heard you because I knew what the answer was supposed to be, but louder, please. It might sound like you're shouting. If Moram thinks you're too loud, she can move.
Do you want me to say it louder? I can.
No, I
He
heard.
knew what it was.
We're dealing with specifically those two objects, so m sub c, m sub s over r squared is equal to, which m is this?
Mass?
S?
Oh, it is mass, but which mass?
Is this a
S.
satellite?
Yes, because we're looking at we're doing the equations of motion for the satellite. So that's mass of the satellite times, and then the formula for centripetal acceleration,
V squared over R.
that's the one I want. Make sure my V's and R's don't look alike.
If you want, you could just write a little tail on the end of the V like you do with your W's.
Hopefully that's good enough for now.
Yeah.
Okay, so, can I simplify that?
Yeah, you could take out M, S, divide it.
All right, divide both sides by the mass of the satellite.
Yeah.
All right, so if I have
You
an
could
object,
probably multiply it by R on both sides, so you
Okay.
can just get one R in the denominator on the left side.
what R is that anyway?
Radius,
Of,
the satellite. Wait, what the hell?
Radius
Earth.
from the center of the satellite to the center of the object that it's orbiting.
okay. So center to center distance is the radius of the orbit. So R would be basically there to there. So we've now reduced this down to big G, mass of the central object over R is equal to V squared.
Square root it to
Well,
get V alone.
not yet. So what I want to do is, if I know how long it takes for an object to go around,
Do we?
for some situations,
Okay.
we know how long it takes for the Earth to go around the sun.
Right.
How long does it take for the Earth to go around the sun?
Roughly 365.24, I think, days.
Okay.
A year.
Is there a reason you went to days? Sorry?
I was just gonna say a year.
Yeah,
Is it just
that's a lot simpler.
Each year is.
I went to days because you don't do 24/7 1.
Perhaps we should.
Perhaps we should.
I guess in that order, 24/7,
I don't remember
52.
what's going on.
All right, so.
It would
So
make-
the speed,
Okay.
so if I know how long it takes to go around, how would I find, what's the formula for the speed?
Distance over time.
Okay, I think I heard distance over time.
Yeah.
You did.
So, in an orbit, circular orbit, what would the distance be?
For that going around Earth?
For something orbiting. For something traveling in a circle.
pi d, like 2 pi, 2 pi r.
Yeah.
Yeah.
So the circumference divided by the period being the time it takes for one cycle of
revolution.
repetitive motion. So for the Earth, the period of the Earth going around the sun, a year.
Yeah.
For the moon going around the Earth, about 28 days. So if I plug that into here,
Okay.
so we now have this gravitational constant times the mass of that central object over r is equal to 2 pi r over big T
Cross out the R's?
squared. You know, won't be able to cross out the
No,
r's.
right, different areas.
So I'm gonna go ahead and square what's in here, so I get 4 pi squared r squared over T squared. And now I want to get my variables on one side and constants on the other.
Okay.
Assuming that the central object, if we're looking at all the things orbiting a central object, that would be considered constant for that system, at least. So I have big G, mass of the central object, over 4 pi squared is equal to r cubed over T squared. So for all the things orbiting the same central object, the distance cubed, the orbital radius cubed, divided by how long it takes to go around squared, should be constant. This was one of Kepler's laws.
Of whose? Kepler?
Kepler.
Kepler.
Johannes
Johannes Kepler?
He spent 40 years of his life looking at data, coming up with his rules.
Incredible.
One of the rules is this. Another rule is that the objects travel in an elliptical orbit. And the other one is that the closer an object is to the central body, the faster it goes. Matter of fact, he was more specific. If I have an elliptical orbit, first off, what is an ellipse?
It's an odd circle.
Okay.
That was
Anyone
just
have
for
a
my
more
fun. I'm not actually sure what definition you're looking for, but I do know that it's basically when you take a cone and you do a diagonal cut on it.
That works also. If I take 2 points,
Right.
you about to tell me something better?
Oh, no, I'm saying right.
Okay.
It's like, tell me next.
If you take 2 points, let's say that I've got, do this on the wall, I take 2 tacks and I stick the tacks into the wall. I take a piece of string and I take the string and I connect it to the 2 dots. I then put my pin here and I stretch it so that the string is now taut. And then I start working my way around so that the string is constantly tight. Badly drawn there. That basically is an ellipse, that the distance from this point to any point on the ellipse to the other point is a constant. That is one of the definitions of an ellipse. One of Kepler's laws is that that all planets travel in an ellipse, and the sun is at one of the focal points. So the sun, and then Earth, as the Earth goes zipping around. And if, let's see if I can draw a better ellipse. That looks more like an egg, but
It works.
we'll go with it. All right, so I have my sun here.
Right.
That if I look at how much area is swept out in a month. So the Earth goes from there to there, let's say the Earth goes from there to there in a month. There's a certain area of that circle, or the ellipse. That's the area swept out. When it is closer, therefore, it's going to be traveling faster. So if this is also 1 month, that area would be the same as that. So whatever's orbiting the sun will sweep out the same area in the same amount of time. Now, 40 years of his life. Now, an amazing accomplishment because he was just dealing with raw data. He had no reason at all for why any of this stuff would be true. This is just based purely upon experiment. All of Kepler's laws can be derived in a couple of hours. I always had this picture of Kepler and Newton meet in a bar, and they talking about what they've been doing. And Kepler says, yeah, I've spent the last 40 years, I'm almost done, I've spent the last 40 years trying to figure out planetary motion. And Newton goes, oh, you're working on that? Got an afternoon, I can show you how to do it. They did not overlap in time. They would not have met in a bar unless there was a zombie involved. However, so I probably give more credit, more time for Kepler than I should. But one of the reasons Newton's laws were accepted so quickly is the fact that he could derive Kepler's laws from it. And I think I included those videos. They are calculus based. You cannot get around it in this case. So if you have had calculus and interested, there's the slew of videos. It also takes into account, in the very last video, the fact that if the Earth is pulling, if the sun's pulling on the Earth must also be pulling on the sun, which means the sun wobbles a little bit, and that's also taken into account. This would be the average orbital radius. If we did it for a circular orbit because we could derive it without calculus, but if you took into the ellipse, this actually is the average radius, orbital radius, and it still works. All right. Questions? You know what we should do now?
Oh, what should we do?
A problem.
No, I was thinking what we should do is figure out when the next test is.
No.
What do you mean no?
As long as it's not tomorrow.
What's wrong with tomorrow?
No.
Because tomorrow's Thursday, and that's one of my busiest days.
Well, it's always gonna be on a Thursday.
We should.
Oh, don't we go
No,
for
that's
break
so
next week?
early, Dr. Fogg.
How about the 17th?
Next week?
Wait,
After fall break? Can we do
We can push it off until the end of the semester, and you could on that last day have, a couple of tests.
No. Can we do it 2 weeks from now?
Why?
Because that gives me 2 weeks to study.
It's
the
chapters 4, 5, and 6, by the way.
17th is about 2 weeks from now.
No, 17th is next week.
Yeah, today's the 9th. It's a week and a day.
And we have fall break. You guys want to be studying over your fall break?
I'm gonna have to be.
Oh, yeah, quick question.
No guys.
Break do we have?
While they're talking about that,
I'm not
right?
gonna
How
have
many
to
days
be.
of full break do we have?
How many-
Oh.
Fall break
here's
is
Tuesday.
Friday through Tuesday.
Okay.
But you don't want an extra
That's
test as studies.
Yeah.
I just want that. Also, you want to know? Let me tell you why I don't think we should have it next week. First of all, when does Master Set 6 due? We don't even know. You're telling me that you want me to complete my Master Set and study at the same time while dealing with?
Because there's no connection between studying and doing the master sets?
No,
Yeah,
it's
that was
not.
not. That was
Yeah,
not
it's
it.
not connected at all because your Master Sets are not the same as your tests at all.
Those questions all came from old tests.
Your old test. When I tell you, I looked at the test last time and I was like, this is not what I was
Dr.
studying.
Fox, please make it 2 weeks from now.
Now, when I was picturing Thursday of next week, I was I keep forgetting that we aren't having classes on Tuesdays. That would just give 1 day for questions. So I have no problem pushing it off 2 weeks, but is there a reason to do it next week? Would you rather do it next week?
We can have the
Ignoring
next
them.
super early.
Okay, you guys decide. It's okay.
Can you
You can do
wait
it 2 weeks
until
or
the
next
hurricane?
week.
do it in 2 weeks.
You can do it 2 weeks, okay.
I'd rather not do it next week because there are hurricanes coming.
Oh.
Yeah, the Hurricane Milton is not supposed to affect us in any significant way.
It's affecting me significantly because I get migraines from it, and there are 3 more.
Even, wow.
Yeah.
Action at a distance.
Yeah, it's
Like,
foreplay at its finest, I'm telling you.
yes. Okay, next test.
So, and you also mentioned master set, is it acceptable for that to be on the 17th?
Yeah,
Same day as, that's lab day, but
that's fine. Then we have like a good day to ask.
and then this would be the 22nd. Why don't we say the quiz on 6?
Oh,
See, by having the test here, we can get more stuff in.
yeah, quiz. Alright.
That's the homework quiz.
Yay, okay.
That full week.
Yes, so excited. So excited.
So the quiz is on the 26th?
Pardon?
The quiz is on the 26th, is that, or 6th?
No, the chapter, so we got master set due on a week from tomorrow, same day as lab. We have the homework quiz on chapter 6 on the following Tuesday, the 22nd.
Oh,
And then the test will be on the 24th.
Okay.
Just don't tell Stephanie.
So glad we got off track to talk about the test. So excited to take this test.
However,
Oh,
it's now time to talk about what happens when two things hit each other.
Collision,
yay.
what's that
In other
about?
words,
Is
Pardon?
that part of the lesson?
this is part of chapter 6.
Okay.
It's all recorded for posterity, I think.
I love this guy. Did you say that?
I think he had recorded as opposed to having it pause during all of that. Yep, it is blinking.
Why these parts do this physics
All right, so we're gonna have two objects.
This is a
This is chapter 7.
Mhm.
I have two objects heading towards each other.